Hello ladies and gentlemen, welcome to page 2 for the unit review for Unit 2 for Pre-Calculus. If you have not completed page 1, please click the link in the top left hand corner to go back to page 1. Or if you are finished with page 2, click in the link in the top right hand corner to move on to page 3. Now without further ado, let's get started. So with number 4, what we're going to do is we're going to organize the all students take calculus. And what I'm going to do is I'm going to look at the sign is greater than 0. So that means that it's going to be either in the first quadrant or also the second quadrant. But then since cosine is actually less than 0, which means that that's where cosine does not, where it's not positive for cosine. So I'm going to remove A, so it's just going to be the second quadrant. The second one, still write all students take calculus, 1 over sine. I'm going to rewrite cosecant. So where is sine not positive? So that's not going to be the first or second quadrant, but where tangent is positive, so that is going to be the third quadrant. And then last, to finish this off, 1 over cosine. So where is cosine not positive? So it can't be positive in the first and fourth. And where is tangent not positive? So it's not going to be in the third, so we're going to be left with, yet again, the second quadrant. So moving on to number 5, we have cosine of the inverse sine of root 3 over 2. So what you have to think about is you have to think about what is going to be the angle needed for sine to get root 3 over 2. Since sine has a restriction from negative 90 to 90, so it's only going to be in those two quadrants, the fourth quadrant and also the first quadrant, we have to think about what angle measurement that's going to be. That's going to be 60 degrees. Cosine of 60 degrees, which is going to end up giving us 1/2. Moving on to the next one, when I think about tangent, I think about it's going to be, it has a slope of -1, so it's going to be down here or over here. But since tangent also has a restriction as well to negative 90 and 90, I'm only talking about the one that's in the fourth quadrant, so it's going to give you 45 degrees, but it has to be negative. So sine of negative 45 degrees, which is going to be root 2 over 2, but since it's in the fourth quadrant, it needs to be negative. Now to finish up this last problem, I'm going to just rewrite this as the inverse cosine of negative root 2 over 2. Now cosine has a restriction of 0 to 180 degrees. So since it's negative, we're actually talking about 135 degrees. Right? It wouldn't just be 45 because that's where it's going to be positive. Then tangent of 135 degrees is going to have a slope of -1, being in the second quadrant. Let's move on to number 6. Number 6 seems pretty confusing because to try to organize an angle for 8/5, what we're going to do is I'm going to change that to inverse sine and then just flip the fraction. So it's going to be 5 over 8. So I can see here that both of them have sine and inverse sine, and I can actually just cancel them out, and what comes out of this is just what is on the inside, so the 5/8. So that is our answer, just like that. Now for the second one, we're going to draw our triangle, and I don't know the angle that will that gives us 12 over 13, so it's important to draw ourselves a nice little triangle. So 13 is going to be the hypotenuse, 12 is going to be the opposite side, and this ends up becoming yet again another Pythagorean triple. But we do it in relationship to that theta. So what I'm going to do here is I'm going to just write theta to use that triangle as a reference and try and figure out what is the tangent theta for this triangle. So use that triangle to figure out what tangent is going to be, and that's going to be 12 over 5. And that's it, you're done. You don't need to figure out the actual angle measurement for this problem. It's just needed to get a value at the end. Number 7, this is where we're going to try and find out two angle measurements in which that will give us the 1/2. So cosine of theta is equal to 1/2. That is going to be 60 degrees, but it is also going to be positive in also the fourth quadrant, so the reference angle for the fourth quadrant is going to be 300 degrees. Tangent, on the other hand, where it's undefined, I always like to think about what is going to be the slope of undefined, so it's at 90 and 270. So I'm going to write 90 degrees and also 270. And lastly, secant of theta, which is equal to 2. Yet again, I don't like working with sine. I don't like working with cosecant, secant, cotangent. So I like to convert them back to something that's more manageable. So cosine, sine, or tangent. So cosine of theta. So I'm just going to flip that. So it ends up being 1/2, and it ends up being that first example for these sets of problems. So it's going to be 60 degrees and also 300 degrees. Moving on to the last problem. Number 8. So this is where you have to find your A, B, C, D value. But what I'm going to use here is I'm going to figure out which equation should I use. Should I use sine or cosine? Since it starts at the min, I'm going to use cosine for this example. So I don't have to have a moving C value. And since it's on the bottom, it's actually going to be a negative value. So it's going to be negative here, just so that I have that listed out. Okay, let's start off with the A. Take the max minus the min, which is going to be -2, divide by 2. And make sure that you keep your negatives, just keep them in mind. So it's going to give us 6 divided by 2, so that gives us 3. B, on the other hand, I go from the lowest point to the lowest point, which is all nicely kind of here. So the period for this example is going to be 2 pi. So it's going to be 2 pi over 2 pi, which gives us 1. C, for this example, since we didn't move it on the y-axis, that's still just going to be 0. And D, that's where the equilibrium is going to be. So you can either take the min plus the amplitude, or the max minus the amplitude. Really doesn't matter. It's still going to just be at 1. And let's finish up our problem. So we get here y is equal to, it's negative because, yet again, we start at the minimum. 3 cosine. My b value is just 1, so I don't even need to write it there. X, I don't need to worry about a minus c because c is 0, and then plus 1. So our answer here is going to be y is equal to -3 cosine x plus 1. Now let's move over to the second example. I'm going to choose this point and these 2 points, and it just makes sense to use sine for this example because you're starting at the equilibrium. And also, it's going to be positive because it starts to go up, back down, and then back up. Okay, let's write down our A values. Our A value here, the max, which is going to be -1 minus the min, -5, divide by 2, which ends up giving us 4, and then 4 divided by 2 is 2. The B value here, which is 2 pi over, now I can see right here to go from the same spots for one full period is going to actually just be 2. So I'm going to write 2 on the bottom, which is going to give us a b value of pi. So I'm going to show you what that's going to look like later. C is going to be 0 because we're still going to be using sine. And D, where's the equilibrium? Since we're starting actually at the equilibrium, it's a good idea to make it just -3. So let's write down our equation. Y is equal to, it's going to be positive, so I don't need to worry about a negative, 2 sine our b value, which is going to be pi, x. Now normally we have the whole deal with parentheses, and we'll be talking more about that later, but since there's no c value, we can just write pi x, and then finish it off with -3. And that's going to be my answer for that one. If you have any questions about any of these problems, please make any comments down below, and thanks for watching.